So welcome everyone. So let us have problems on Coulombs law in this second session. What we discussed was about the Coulombs law. We have to find out the forces between the charges, and for that we have the formula Coulombs law, which is Q1 Q2, that is product of charges, divided by 4 pi epsilon naught r square. So Q1 and Q2 may be our test charges, and we have to consider one as source and one is destination. This is very important thing in rest of the topics also. We have to find out who is the source and who is the destination. So one charge applies the force and another charge effaces the force. So the one who applies force is the source and the one who is facing the force is destination. So what other things we require in numericals? With the value of epsilon naught, it is 8.85 into 10 to the power minus 12 farads per meter. We know pi 3.14. So directly we can keep this value in 1 upon 4 pi epsilon naught, which comes to 9 into 10 to the power 9. Where r bar is the distance vector. And this distance vector we can calculate by a simple formula by subtracting the source point from destination points. We'll see what is it. And this particular vector r bar, we have discussed about it. Vector r bar is combination of magnitude and direction. So from here direction we can write as r bar by r. Now, if we consider that, now let us explore this expression. Our air is a mobile tower. From there, our mobile signals are getting emitted. And you are available somewhere here in space. And your mobile phone is receiving the signals. So as we discussed, in the antenna there will be vibration of electrons and the photons will get released in the terms of electromagnetic energy and they will travel and you will get the signal. But what happens with respect to the distance? If your distance increases from the antenna, what happens? If you go away from the antenna, will you get the same strength of signal? No, your strength will decrease. So if we consider this distances as r, then as we go away from the source, what is there? There is the source who is applying the force, and here we are the destination. As we increase the distance, the force also decreases. That is force per charge. So for this we have some direction component. How we calculate direction component? Source point. Suppose source point have some coordinates, say 0, 1, 2 or something, and the destination may have some other point 3, 4, 5 or anything in the space. So this r bar is calculated by the source points and destination points will decide that. So from these points we have to minus these points, that we will see directly in the examples. So here also you can see force is inversely proportional to the square distance between them. As distance increases, the force decreases. If this force decreases, we get the less signal as our distance increases. So let us see an example directly. So we'll see simple steps to solve. In any given example, first we have to find out the source and charge destination, where it is, and then we will try to draw the setup of given charges. Then we will calculate the distance vectors and magnitude. And the formula for calculation this distance vector will use as destination points minus source point. Then we can calculate the unit vector using AR cap is equal to R bar by mod of R bar. Finally, we will use the Coulombs law formula. If it is only magnitude, we will use it without direction. If it is with vector form, we will have to add the direction component. And this calculated AR cap we have to add here. So let us move to example. So say here we have one example, and we are asked to find the force on point charge of minus 100 millicoulomb at the point P. Point P location is given as 2, 0, 5 meter in free space due to another point charge of 300 coulomb at the point Q, which is located at 1, 2, 3 meters. Now here we are using the Cartesian coordinate system. Here he is giving us the position of two different charges. So what is our first step? First step, we will find out who is the source and who is the destination. Source is the one who is applying the force, and destination is the one who is facing the force. So what he is asking us? He is asking us to find the force on a point charge. On this point we have to find out, and where it is located at P. So say this is point P charge, and due to whom another point charge of 300 coulomb. It is present at some Q position. So Q, due to Q, that means Q is applying force on P. So let us note it down, this example here. So I should pause and I will note it down here. So here we have to find out a force on a point charge. So we will note down the data. Here we have to consider a space where our charges are located. So say this is our Z axis, the vertical axis. The line which is going like this, we'll call it as say Y axis, and the line which is coming towards us is say X axis. These two directions are interchangeably. For simplicity, for remembering and for maintaining uniform thing, we will consider that the X is the axis which is coming towards us. So these are three axes in space. First we will find out the location of charges. So first he is saying that there is a point P, say let us call it charge 1. Charge 1 is of minus 100 millicoulomb, and where it is located? It is located at point 2, 0, 5. So what is this location? So whenever the location of points are given, that means they are present in space. So first position is say of x-axis. The second value is value of y-axis, and the third one is the height, the z one. So on x, how many places we have to move ahead is 2. So let us calculate from the origin. So the line where all the lines connect together is the origin. Say this is origin O. So on axis, say this is 1, 2, 3, 4, 5 and so on. On y-axis also we can have, say this is origin 0, then 1, 2, 3, 4, 5, 6 and likewise. Then on z-axis we'll mark like 1, 2, 3, 4, 5 and so on. So let us find out the point P. First we will find out the points on the floor, on the surface. So point P, on X it is 2. So this is 2. And on Y the value is 0. So that means this charge is present on this point itself. Sorry, on this line itself. But there is some height for this point P. What is that height? Say it's 5. So Y is 0 at this place, X is 2 at this place. So we have to move to the 5. So the height of this particular line should be 5. So I will pause and I will make a line here. So here we have, so this is 5. Sorry, I have to make line from here. So previously by mistake I had drawn a line here. So what will be the point here if I consider this place? On this place X is 5. On this place Y is 0. And on this place Z is 5. So this is 5, comma 0, comma 5. And what is our actual point? We have 2, comma 0, comma 5. So here we have 2, this one, and 0, and here is the 5. So here the Q1 is located. So here we will write it as, say, Q1. This is the position of Q1. So similarly we have another charge given that is called as Q2. And Q2 is given, it's 300 microcoulomb. So this is microcoulomb and located at 1, 2, 3. So Q2 value is 300 microcoulomb. It is located at, say in example it is given as Q 1, 2, 3. Again similarly, on x-axis its value is 1, on y-axis its value is 2, and on z its value is 3. So on floor first we will find out. So on x it is 1, this is x-axis, on y it is 2. So we will extend this one, this line here, and from y we will extend this line. So on floor this is somewhere here. What is value here? This is x1 and y2. But we don't have only 2 components. We have third component, that is z. So we have to extend it up to 3. I will pause and I will make a line. So here it is like this. So here floor 1, 2, and if we extend the height to 3, so this point will be Q2 and its location is 1, 2, 3. What are the location for Q1? It's 2, 0, 5. So we have located the point charges in space. Now we have to draw the distance vector, what we are calling distance vector, r bar. This distance vector between the given charges. And what will be the direction of this distance vector? This distance vector direction will be from source to destination. So who is our source and who is our destination? As per example, find the force on point charge. 100 microcoulomb is the destination. On him we have to find out the force. So Q1 is the destination. And who is applying force? Q2. So this one is source. So how we find out R bar? R bar simply we find out as, say, destination points minus source points. So destination points minus source points. I have drawn a line from source to destination. Here we can see that Q2 is the source. So this charge is applying force on this charge, and the line joining them is called as the distance vector r bar, and this r bar will be given by the destination point minus source point. So destination is for x, destination point is 2. For this one it is, for source it is 1. So 2 minus 1 will be 1. So similarly we will write down for all. So this R1 will be equal to the first for x. So destination value of x is 2, source is 1. So say 2 minus 1, and its direction is ax cap. Then plus the next y component. Y component is 0 for destination and 2 for source. So 0 minus 2. So it will be 0 minus 2 ay cap, plus the third one will be destination z component 5 minus 3. So it will be 5 minus 3 az cap. So this r bar final value will get as ax cap minus 2ay cap plus 2 az cap. And if we calculate the magnitude, the mod of r, or simply r, the distance between them, it comes to say the square root of 1 square plus minus 2 square plus 2 square. So it will come to minus the square root of 9, and so finally it will be 3 meter. So we have r as 3 meters. So that means the distance between them is 3 meter. From 3 meter he is applying the force. So now what is our remaining task? We have to calculate the force using Coulombs law. So what is Coulombs law? Coulombs law is force equal to Q1 Q2 divided by 4 pi epsilon naught r square. So if we have to calculate only magnitude, we can simply keep these values, or if we want to calculate the vector form, we have to keep it in the formula for vector form. So let us calculate magnitude first. Say force Q1 we know it is minus 100 into 10 to the power minus 3, and Q2 is say 300 into 10 to the power minus 6. So this is Q1, Q2, and 4 pi epsilon naught constant value is 8.85 into 10 to the power minus 12. The unit of force is newtons. And what is R? R square. R calculated R is 3 meter. So here we will get 3 square. R square is say 3 square. Here I am using all the values for practice purpose. For here, but you can use 1 upon 4 pi epsilon naught value, the constant value we have calculated. It is 9 into 10 to the power 9 newtons meter square per coulomb square. Directly we can multiply this value with the Q1, Q2. So if we calculate this, we get some value around minus 29972.68 into 10 to the power 19 newtons. We can calculate this. Now if we have to calculate, this is about magnitude without bar. If we have to calculate the force in vector form, what we have to do? We have to add the direction component. So we have formula for that, Q1 Q2 by 4 pi naught epsilon naught r square into AR cap. We can calculate AR cap. For AR cap, we have AR cap is equal to R bar divided by mod of R bar. We have calculated R bar. So this is R bar, AX cap minus 2 AY cap plus 2 AZ cap, and divided by mod of R bar is 3. There we can write it as AR cap is equal to AX cap minus 2 AY cap plus 2 AZ cap divided by 3. So if we keep this value of AR cap in this expression, already we have this force value. So we'll get some value of F bar, that is vector form. There we'll get answer in terms of all direction. Force will have component in X direction, Y direction as well as Z direction. What is the X cap? The unit direction component in X. AY is direction component in Y and AZ is direction component in Z. So it will be equal to around say 99990.8 AX cap plus plus 19981 AY cap plus minus 19981 AZ cap Newton. So this is the problem. Now let us see the same thing with respect to some 3D animation. So what we did, we have given 2 points in space, and we have identified the point P in space as 205 Q1 and 123 Q2. So first we have located points on the floor. So for X it is 2 from origin, on Y it is 0, so on the same line, and the height is say Z. Similarly, we have set up like this. So 1, 2, 3. So X1, Y2, and the Z is 3. So the thing is that we have to imagine these points in space, how they are located. Then what we did, we have drawn the unit vector R bar from source to destination. This distance we have calculated as 3 meters. How we calculated? Destination points minus source points. So X point minus X point, Y minus Y, Z minus Z. That is the position vector, that is direction from source to destination. Now let us see the different various setups in examination, how we may get the problems, and you can solve them easily by using our steps. So there is another example here. What he is asking is giving us 4-point charges. Say there are 4-point charges of 10 Coulomb at the point, and the points are placed in free space. And what are the locations given? Say first is 1, 0, 0. Second one is -1, 0, 0. Then 0, 1, 0, 0, -1, and say 0. So what we have to do? We have to determine the force on the point charge of 30 Coulomb present at 0, 0, 1. Now here you can notice that here we have one positive X, then we have one negative X. Then second component here Y is given, positive Y. Then we have one negative Y. That means there are 4 charges present on positive X, positive Y and negative Y. And where we have to find out the force, the destination is located on Z axis at height 1. So if we see the setup, so say Q1. So this is our Z axis, this is Y axis, and this is X axis. So if this is positive x-axis, back side we have one negative x-axis. Similarly, if this one is the positive y-axis, opposite side we have one negative y-axis. So all the 4 points are applying some force on a single point. So one is located at x equal to positive 1. Other components are 0. That means on the same line. Similarly, on y we have 0 minus 1 minus 0. Then minus y plus negative x. And the destination is present on the z axis with height, some height 1. So how we will solve? So we can have two methods to solve this one. First, we have the same formula for Coulombs law. So we can have, we are calling them as Q1, Q2, Q3 and Q4. So if Q1 is applying some force, first let us calculate Q1. And the distance position is say R1. So again we will use the same steps. So for the calculation of distance vector R. So for Q1 it is R1. We have destination point minus source point. Destination point first we have 0. X is 0, Y is 0, but Z is 1 here. So 0 minus 1 will get minus AX cap. The next one will be 0. And the third one is say 1 minus 0. So it will be 1. So we will get AX cap minus AX cap plus AZ cap. That will be R bar. And it's what will be the modulus? The mod of R bar, square root of 1 square plus 1 square. So we will get square root of plus 2. So from there we can add this value. Square root of 2 will be the mod of R. So we can calculate AR1 cap. Then similarly we can calculate AR2 cap, AR3 cap, and we can add all the forces, all the 4 forces to get the net force. Or else we can take a single formula where we will take the summation of forces at single place and we can calculate the force. The detailed answers PDF I will share in the group. The next case, if we consider that there is another example where 4 like charges of 30 coulomb each are given at the 4 corners of a square, and the diagonal of which measures 8 meters. Find the force on 150 coulomb charge located at 3 meters above the center of square. So what is given? First, we are given that there are 4 charges present on the 4 corners of the square. But he has not asked us from where or whether it is exactly on which plane. So for simplicity we will consider that it is like this. So this is z-axis, x-axis and y-axis, and this is the surface where we are considering the square which is having 4 charges at 4 corners, and at its center we have one charge which is above the ground with some height, that is 3 meters. So this is, what are the components here? So for the calculation of component we have to use a different mathematical formula, and we can have the calculation. Here one more thing you can concentrate, that if we look at the 3-dimensional diagram we can see the clear picture that there are 4 charges and they are located at 4 corners. Then we have one, and all of them are applying some force. So we have 4 forces, force 1, force 2, force 3, force 4. So the total force, net force, will be summation of all the forces. So individually we can calculate the forces using the Coulombs law. Same method, we will find out the R1, R2, R3, R4. We will calculate AR1 cap, AR2 cap, AR3 cap, AR4 cap according to the number of charges. But if we look at the same diagram from the top view, we cannot see the exact height of this point B. We feel that okay, it is at the center of the square only. When we have some 3-dimensional look, of course we have to do it in our imagination. then we get the clear picture. So we have to find out these distances and we have to keep in the formula of Coulombs law. So there is another one example now. In this case, there are 8-point charges. They are applying some force. These 8-point charges of 10 Coulomb are placed on the 8 corners of a cube as shown in figure. So we have to find out the force exerted by 7-point charges on the charge placed on origin. So here you can see on the cube there are charges present on the 8 corners, and at center origin we have one charge where we have to calculate the force. So we can find out, say, for if we consider this charge, we will find out what is R bar. So this is destination, this is source. Here we will calculate force 1, then force 2, force 3, 4, 5, 6, 7. And for calculation of total force, we have to take the summation. Then there may be one more example. We will see the setup. Here we have charges of 0.25 located on the vertices of equilateral triangle of 10 meters of side. Find the magnitude and direction of force. So in this diagram, we consider a triangle like this, z-axis having one charge, positive y-axis having second, and negative y-axis having third charge. So for finding out the distances, we get, say, these are 10 meter, 10 meter, and this is 10 meter. So this height will get around 8.7 meters from origin. In similar way, we will calculate R1, R2, and R3, and we have to take the summation. So basically, we have to use the same Coulomb's law formula for calculation of forces, but there may be a single charge or there may be multiple charges which are involved in the system. So I hope this concept is clear. In the next video we will discuss about the electric field intensity and the problem based on the electric field intensity.